Hey everyone, and welcome to the channel. If you're preparing for a data analyst or software engineering interview, or you just want to seriously level up your SQL skills, you have come to the right place. Today, we're going to walk through 25 essential SQL queries. We will start with the absolute basics and work our way up to advanced concepts like common table expressions and window functions that will really make you stand out. We will be working with a simple and classic database schema, employees and departments. To follow along, and I highly recommend you do, check out the description below. I have put a link to a script with all the create table and insert statements. You can paste that into any SQL compiler like SQLite Online and you'll be ready to go. Alright, got your editor open? Let's get started. Okay, let's dive into our first set of queries. These will cover the fundamentals that you will use every single day. First up, a simple one. We want to see the full name and salary of every employee. Here we are using select statement to specify the columns we want. Instead of just first name and last name, we use the concat function to join them together with a space in between. We give them this new column an alias, a temporary name as full name to make our output clean. And of course, we pull this data from the employees table. So let's run it. So as you can see, you have a clean list of full names and their salaries. Simple and effective. Let's move on to the second question. Find all employees who work in the engineering department. Alright, let's filter our results. We only want to see the engineers. So here we use where clause to filter our rows. We want to match the department ID, but we don't know the ID for engineering off the top of our head. So we use a subquery, a query inside another query. We select the department ID from the departments table where the department name is engineering. And then we run it with the outer query where we select all the employees whose department ID is equal to the one of engineering. Perfect. Only the employees from the engineering team are listed here. As we can see, the department ID is just one. Now let's work with the dates. List all employees hired after January 1st, 2020 and order them by hire date. So we run the query. Again, we use a where clause for filtering, this time on the hire date column. Then we add order by hire date. By default, order by sorts in ascending order, which is exactly what we want. And as you can see, we get a list of all the employees hired since the start of 2020, neatly sorted. Now let's look at some aggregate functions, and these are incredibly useful for summarizing data. First, we want to get the total number of employees. So we'll simply use a count of employee ID as total employees from the employee table. There you go. We have total 15 employees. Next, we want to calculate the average salary of all the employees. So again, we calculate the average with the function average and use it as average salary. There we go. We got the average salary as 97800. And then we find the highest and lowest salaries. So for that, max and min do exactly what they sound like. They find the highest and the lowest value in that column. So these are the building blocks of any data analysis. Let's run this query. So we've got the highest salary as 1,50,000 and the lowest as 62,000. So this is the classic. We need to retrieve a list of all departments and the number of employees in each department. For this, we need to combine aggregation with grouping. So as you can see, we are selecting the department name, the count of employee ID as the number of employees from departments, left join employees on department ID, group by department name and order by the number of employees. So what's we doing here? We need the department name from the departments table and the employee count from the employees. So that's why we're doing this join. Why we're using a left join? Because it ensures that all the departments are listed even if it has zero employees. Since we're using an aggregate function which is count, we must use group by. This tells the database to run the count for each group of department name. And finally, we order by the count to see the biggest department first. Now let's run the query. There you go. So for each department, the number of employees are listed over here. Since we do not have any employee in the finance department, the value for number of employees has come up to 0. Alright. Now, what if we only want to see the large departments? We can filter on a group results. So this query looks similar, but notice the having clause. You can't use where to filter on an aggregate result like a count. Where filters rows before they are grouped, having filters the groups after they are created. So we group the departments, get the counts, and then having keeps only the groups where the count is greater than 3. So now if we run the query, we should only get the engineering and the sales department because the number of employees are more than 3. So let's run it. Perfect. So we just get the engineering and the sales department employees. So next we have couple of other queries which are similar to the one we've used above. List the name of all employees along with their department name. So what we're going to do, we're going to just do a simple join on the employee and the departments table on the basis of department ID. Get the employee names and the departments. So this inner join only return rows with the data matches in both the tables. So as you can see, you won't have finance over here because there is no employee in the finance department and there is no matching record for that particular table. Next, find the employees who do not have a department assigned. So this should definitely get us one of the employees which is there in the database who can be a new hire and doesn't have a department. So we use is null. Is null check is the key over here. Select the first name, last name from employees where department ID is null. And select the entire query. There you go. Thomas Anderson is your employee who doesn't has a department allocated. Next, List all employees and their manager's name. So we have a self join over here. As you can see, we're joining the employees table. We connect both the employees table where the employee's manager ID matches the manager's employee ID. There you go. So the employee James has manager as Michael, Maria has Linda. Now, just because Michael, Linda themselves are managers, they don't have a manager name over here, so it comes as null for them. Perfect. Now we move on to question 12, wherein we find the top three highest paid employees. We order by salary as descending to put the highest salaries first and then use the top function to grab only the top three rows. There you go. We get the top three employees. Get the list of employees whose salary is greater than the average salary. So now we use another subquery. Why? Because we need something to compare the salary with the average salary. So we find employees whose salary is greater than overall average salary. The subquery select average salary from employees calculates that average for us. Let's run the query. So these are all the employees who are earning more than the average salary. Question 14 says update the salary of David Johnson to 1,25,000. So currently you can see it is 1,20,000. So we use an update function over here. It's a data manipulation language command. It changes the existing data. So we update employees, set the salary as 1,25,000, where the first name is David and the last name is Johnson. Let's run the query. And to validate the query, we will select the employee, their first name, last name, and salary, where the employee ID is 103, that is of David Johnson. So for David Johnson, now the salary is updated as 1,25,000. And finally, we have a delete clause used here. Delete the employee Thomas Anderson from the employees table. So note this is a delete query and we need to use a select statement to verify again the deletion. So we just delete the employee wherein the first name is Thomas and the last name is Anderson. Let's quickly run the query. It's been performed. And just to verify our result, we know the employee ID was 150. And again, this returns you nothing. Alright, you have mastered the fundamentals. Now let's move on to the advanced queries. These are the ones that can really set you apart in an interview. Find the second highest salary in the employees table. It's a classic interview question to test your logic. The subquery finds the absolute maximum salary over here. The outer query then asks for the maximum salary that is less than the absolute maximum, which logically gives you the second highest. So we select the maximum salary as second highest salary from employees table where the salary is less than the maximum salary. Now let's run. If you notice before, the maximum salary was 1,50,000. Now it should be less than that. Perfect. We get the second highest salary, which is $1,45,000. Next, list employees who have the same salary. So our purpose is to find the duplicate values across different records. Over here, we're using a self join. This is another self join. It joins the table to itself on the salary column. Okay. The condition employee E1 dot employee ID is not equal to E2 dot employee ID is critical. Why? Because it ensures an employee isn't matched with themselves. So let's run it. None of the employees got the same salary. Next, find the employees who earn more than their manager. Oof, lucky people. A practical problem that combines a self join with a comparison. So, how it works? Similar to the manager lookup, this query performs a self join. It then adds a where condition to compare the employee's salary with their manager's salary. So, we're doing nothing. We're getting the first name, last name, salary, and the manager's first name from employees table. We're joining on the basis of manager ID and the employee ID, where the employee's salary is greater than the manager's salary. Let's run the query. Oof. So Charles is earning more than the manager, who's Jennifer. Next is list all departments that have no employees. So I'm sure finance department should be the one who should be listed here. So what we're doing, we have to find an empty category or group. And how is it working? It's working on the basis of left join, which ensures that all the departments are included. And in the having clause, we look for departments where the count of employees is 0. So let's run it. And there you go. You get the finance department as the one with no employees. All right. Let's move on to this question wherein we rank employees based on their salary within each department. Get this down. Perfect. So to perform calculations on a window of related data without collapsing the rows. That's what our purpose is in this query. And how we're going to achieve that? We're using the window functions like rank and over, which calculates a rank. A partition by department dot name. This is the key. It divides the data into separate groups, which are basically partitions for each department. The ranking is done independently within each partition and restarts for the next. Order by salary descending, this one, it tells the function how to assign the ranks within each partition. Highest salary gets the rank 1. So now let's run it. So as you can see, we get the first name, last name, salaries, and the department name. Another thing to observe is the ranks will be re-allotted every time a new department is there. So 1, 2, 3 for engineering, again 1, 2 for human resource, and same goes for marketing and sales. Next we have get the cumulative salary for each department. So our purpose is to calculate a running total. And how we're going to achieve that? We again you going to use a window function which is sum over, and this calculates a sum over the partition. The order by hire date, it makes it cumulative or running sum, adding each employee's salary as it moves through the hire date within the department. So we select the first name, hire date, salary, department name, and then we find the sum of the salary over how we are going to partition it on the basis of department name and order by the hire date as the cumulative salary from the employees and the departments join. Let's run it. There you go. You get the first name, the hire date, the salary, the department name, and the cumulative salary. It just keeps adding up for individual departments if we do. Okay. So the next question is categorize employees into high, medium, and low salary bands. We're just going to segment data into custom categories. So the case statement acts like an if and else block. It goes through each condition, and when one is met, it returns the specified value. This allows us to create a custom label or group on the fly. We're doing what? We're selecting the first name, last name, salary, and then we're assigning a salary band in the employees table. So let's run it. Perfect. So as you can see, all the employees have a specific salary band on the basis of the salaries between 1,20,000 and 80,000, and it is shown over here. All right. Next, we have use a common table expression to find employees who earn above their department's average. So the purpose is to break down a complex query into logical, readable, and reusable parts. And how it works? A common table expression CTE started with the with keyword creates a temporary named result department average. In this CTE, we calculate the average salary for each department. Then, in the main query below, we can join to this CTE as if it were a real table, making the final comparison clean and easy to read. So, in the with CTE, we just finding the department average for each department, and then over here, we're joining the two tables and getting the employees who earn above, like greater than the department's average salary. So now let's run it. Okay, here we go. So you've all these employees in the engineering department who earn more than the average salary for the engineering department, then the sales, marketing, human resource, all the departments. Next, find the employees who were hired most recently in each department. So it's a common nth group record per group problem. So what we're going to do here, it uses the row number window function within a CTE. So we again you are going to use a common table expression here, latest hires, and that is going to use row number and partition as well. So it assigns a sequential number to each employee within their department on their hire date. The main query then simply selects the rows from the CTE where the row number is 1. So here we're getting the row number. We're partitioning on the basis of department ID in order by the hire date. And then finally, we're getting the employees where the row number is 1. Let's run it. So it gives the employees which were recently hired in each of the department. Finally, calculate the difference between each employee's salary and the average salary of their department. So this will see how an individual compares to their local group average, and it will again use a Windows function to get the department average on the same line as the employee's data, average salary over partition by the department name, and calculate the average for each employee's department without collapsing the rows. We can then subtract this from the individual salary in the same select. So what we're doing, we're selecting the first name, last name, department, and the salary of the employees. Then we're getting the average salary by partitioning on the basis of department ID as the average department salary. Then we're getting the employee's salary minus that average salary that we've got as the salary difference, and we're joining the employee and department table on the basis of ID. So let's run it. Perfect. So we get the first name, last name, department name, salary, the department's average salary, and then we get the salary difference. And there you have it. 25 SQL queries that take you from the fundamentals of selecting and filtering data all the way to advanced aggregation and powerful window functions. We covered joins, subqueries, CTEs, rank, row number, and so much more. The absolute best way to get good at SQL is to practice. Take this dataset, modify these queries, and try to answer new questions you come up with yourself. Maybe like what's the average tenure of an employee in the sales department? Who is the third most recent hire in the company? Just challenge yourself. If you found this video helpful, please give it a thumbs up, subscribe to the channel, and hit that notification bell so you don't miss future videos. And leave a comment below with any questions you have or what SQL topics you would like to see covered next. Thanks for watching and happy coding.